So in this video we are going to study Coulombs law, and we are not going to talk about the technical specific the experimental situation, how we obtain this, just the result and how mathematically speaking we are going to deal with this force. The Coulomb law, what it say basically is that if you have a charge, let's say put it on the origin, and let's say that you put on x and y, so means that the vector will be, if x is equal 3 and y equal 2, the vector position of the negative charge will be xi 3i plus 4j. Okay, this is the vector position of the negative charge. What it say, Coulomb law say that the force acting on the negative charge, acting due to the positive charge, due to the positive charge is k, the value of q positive, this will be positive. The value of q negative, this will be negative. Divide, so the product will be negative, of course. Divided by the distance squared. This is a quantity that is always positive because it's the distance squared. The distance is always positive. But if you think that it will not be the distance, if you think that the distance could be negative, going square it will be positive. So this is always positive. By the direction u sub r. The direction u sub r goes from the source. So we are going to find the force on the negative charge due to the positive charge. So the source is here. So u sub r is the vectors that go from the source to the point. So u sub r, you can imagine u sub r here. So the force in this case will be parallel to u sub r, but will be negative, will be in this direction, f. F will be in this direction because if something negative is whatever you calculate, it will be minus u sub r, minus something, minus 5. K, let's say that Q plus is plus 1 Coulomb, Q minus is minus 2 coulombs. So F on the positive charge due to the negative will be K 1 by minus 2 multiplied by minus 2 divided by the distance square, whatever is the distance, 5 meters. Okay, 5 meters, 5 square. And the vector u sub r. And this product is negative, so the force is in the negative direction of u sub r. And how to find u sub r? U sub r is the position vector r divided by the magnitude. We have done many times in the class. So it will be x divided by x squared plus y squared square root in the y direction plus y divided by x squared plus y squared square root in the j direction. This is the vector position. This is the unitary vector on the direction of r. So this is what it say Coulomb law. What it say Coulomb law by the force acting on the positive charge due to the negative charge. What do you think that it say? It say K, Q positive will be positive, Q negative will be negative, and the product will be negative, divided by the magnitude of R squared, the magnitude that separates both charge. And what is the vector here? The vector is u sub r prime, because it goes from the source, that now the source, I'm looking for the force due to this negative charge, due to the negative charge acting on the positive charge. So the force should be attractive because positive and negative is going to be attracting. And I want to show you that this equation is an attractive force. So U sub r go from the source to the point of observation, what the positive charge is. So the force is this is U sub r prime. U sub r prime. So the force is negative U sub r prime. Wow. So if U sub r prime goes in this direction, negative U sub r prime will go in this direction. So the force will go in this direction. Catch it? So on this one, we see that the forces are attractive in this case. Let me remind you. You see, let me go to another page, please. Let me see, to go to another page to a more clear draw. Let's say this is the positive charge. This is the negative charge. This is the negative charge Q minus. There is a vector growing from the negative charge to the positive charge. Yes, this is the vector R going from the negative charge to the positive charge. So the force on Q plus due to Q minus, we said that is K Q plus Q minus divided by the magnitude R squared. What is the magnitude? These are, let's go to call this R prime, and by the U sub R prime. Now the question is, who is R prime? Because we knew that R, from the first case, was xi R of Q positive, Q negative, will be xi plus yj. Now we want to look at R prime. It means R prime, the position of Q plus, due to from the source, from Q minus. So what is R prime? R prime is this vector plus this vector. And what is this vector? Is the vector minus I j minus x I. So it's clear that R prime Q mass is minus R Q minus. Well, so I want to be sure that this is U sub R prime. And the U sub R prime is basically R prime, the vector, divided by the magnitude, R prime. But the magnitude of R prime is the same magnitude that R, that was this vector. And R prime is the vector minus ij minus xi divided by a square root of x squared plus y squared because it's the magnitude of R prime. I hope this is clear. Now, let's go to make an example, an easy example. One example, but before doing the example, do you see this equation? Yes, a moment. Okay, this equation is wrong. The equation that I want to put is that R Q plus, meaning this is Q plus and this is Q minus, I call R Q plus the vector that goes from the origin, from the source to Q minus, is equal to R prime Q minus negative. So sorry, this is the vector r prime q minus. So this is the equation. I'm sorry about this. I made a mistake. So let's go to make an example, an easy example, okay? Okay, let's go to an example. For example, this example could be this example, that is one positive charge here, one positive charge here, and one negative charge here. So let's go to put numbers. Let's say 1, 2, 3, and 1, 2, 3, 4. Let's say the position of the Q minus of the charge here is 3, 4. And the charge, let's say that we put 1 coulomb, 2 coulomb, 3 coulomb. And we pretend to find the force made on Q minus due to Q1. So this is Q1. And also we want to find the force on Q minus due to Q2. This is 1, Q2. Q2, that is 2 coulomb. 2 coulomb, okay. So let's go to find. So we find this vector, the vector that goes to find F of on Q minus due to Q1. We find this vector. We call this vector the vector R1. So the force will be K, Q minus, Q1, divided by the distance square. The distance square is 3 square plus 4 square. And the vector u sub r. And the vector u sub r is this vector, a unitary vector of the direction of r. Because r, the vector r1 is 3i plus 4j, the vector u sub r1 will be 3i plus 4j divided by a square root of 3 squared plus 4 squared. This is 25, this is 5. This is 3, 5i plus 4, 5j. This is the vector u sub r. And the magnitude of this vector, you know how much is the magnitude of u sub r1? 1, check it, is 1. So the vector here is the vector u sub r1. And the vector u sub r1, let's go to put now the numbers, is k, 9 by 10 a la 9. Q minus, I said Q minus is minus 3 coulomb, Q1 is plus 1 coulomb, divided by the distance that separate, which is distance squared is 25, and multiply by the unitary vector. And the unitary vector, I'm going to write here, the unitary vector, I found it like 3, 5i plus 4, 5j. So this is f of q minus, f acting on q minus due to q1. Can we find f of q minus due to q2? Same thing. You put the vector r2, you find u sub r2, and you write the equation for f q minus on q minus due to q2, which is k q minus, whatever it is, with his sign, q2 positive sign, q2 positive, I said is q2 is 2 coulomb plus 2 coulomb, divided by the distance square, but now the distance square is 4 square. This is the distance. And u sub r, and the vector that go from Q2 to Q minus is the vector U sub r, and clearly is the vector J. So I sum this vector. So let's go to sum. This is positive with negative is attractive. So the force FQ1, this force, if you represent, must be on this direction. This is F on Q minus due to Q1. So we have the Q minus, we have here the minus the charge, the minus 3 coulombs. We have one vector here, one force here, F on Q minus due to the 1 coulomb, to Q1, and the other force is positive and negative is attractive. So, oh, also attractive, yes. I put it two attractive force, so will be like this. And this force is exactly this force, this one. Let's go to right. F on Q minus due to Q2 will be K. Q minus is minus 3 by Q2. Q2 is 2 divided by the distance square, 4 square, in the J direction. But if you see this minus sign, minus 3 by 2 is minus 6. So it's going in the direction of minus J. So that is why it's called, and the magnitude of the vector is 6 divided by 16. 6 by 16. K times 6 divided by 16, J in the minus direction. This is the force, correct? So I have to sum this force. How you sum this force with this force? Where is the other force? With this one. How you sum it? No way, you know how to sum. So you sum. We'll do it later in electrical field. Let's go to now to define electrical field. And you'll see if we made again the same problem, you see how it become easier in two steps. Let's go to another page, page number 4. Okay. So we define the electrical field. So we have a charge here, let's say Q plus, and we find the electrical field produced by Q plus like this one. The force due on any charge Q test, the force due to any charge Q test, that we are going to think that Q test is always positive. So the force will be repulsive, like this, F will go like this. So we define the electrical field produced by the charge Q plus, this one, on the charge Q test T, like the electrical field is this force divided by Q sub T. So will be, what will be the force Q? The force on Q sub T will be K, Q plus, Q sub T divided by the distance square and the vector U sub r. And this is divided by the Q test. So the electrical field produced by a point charge Q plus, the electrical field produced by Q plus is K by Q plus divided by magnitude of R square U sub R. What is the, so if I know the electrical field, I know the force, because the force on Q test will be the electrical field created by Q mass multiplied by Q test. And this is what you have to know about electrical field. The other thing that I have to know, that you have to know about electrical field is the following thing. You know that in nature, in nature, there are scalar field and vector field. The electrical field is a vector field. What does it mean that it's a vector field? It means that at any point in space, any point that you imagine, let's say that this is a Q plus, at any point that you imagine, there is a vector association for every position that you can imagine. In this case, the electrical field is simple, have a value k q plus divided by magnitude of r squared in the direction of u sub r. So you draw the vector r, you imagine the vector u sub r, which is a unitary vector, so at every point there is an electrical field associated. This is the electrical field at this point. At this point, if you put Q test here, the electrical field will be like this. We'll have a magnitude and we have a direction. At this point, the electrical field will be lower because the distance is smaller, but will be in this direction because this is the direction of u sub r, and so on, and so on. If I'm here, the electrical field will be very intense in the direction of u sub r, and very intense. Well, this is what you have to know. So what I was telling you is that there is a scalar field and vector field. In a vector field, you associate a vector to every point in space. So, so imagine, for example, a river. You can imagine a river, a vector velocity, a vector space of velocity. You can imagine that the space at every point of the river there is a vector velocity. So the river maybe here goes faster. So at every point of a space there is an association with a vector. In this case, the vector is the vector velocity. In the case that we deal, the vector is the electrical field that creates the source. So we associate at every point of a space a vector, a magnitude in a point, and a direction. When we deal with an scalar field, we deal with a different thing. An scalar field, we associate with every point in space a number. For example, the temperature is a field. You associate with every point xy, you associate a number. For example, let's say the temperature, you imagine a flag, 30 degrees on this point. 32 degrees. So there is a function f of xy or t of xy that will say at every point what is the temperature. So it's like a flag here that will say the temperature 33. So it's going up. It's going on the x direction, it's increasing the temperature. So you can put it on the y direction, maybe 31. 32, so it's increasing the temperature. This is an scalar field because there is no direction associated with a temperature. There is only the value at this point. So temperature are scalar field, electrical field are vector field. So now I'm going to stop a little bit. Give me 1 second. So now we are going to solve exactly the same problem that we had. I hope that I will remember correctly. Is 1 Coulomb here, 2 Coulomb here, positive, and minus 3 Coulomb. But we are going to calculate the force on Q3, the total force on Q3, but using the concept of the electrical field. Meaning like this, meaning that we are going to erase the charge Q3. Let's go to erase the chart Q3. So we erase the chart Q3 and we leave it for the end. So now we imagine that at the point 34, this point, we are going to calculate the electrical field. At this point, at the point 34, we are going to calculate the electrical field. The electrical field produced by the first charge, this one from 1 Coulomb, is E1, I'll call, is K, the source Q1, 1 Coulomb, divided by the distance square. The distance square is 5 square, and is in the direction of U sub r. And the direction of U sub r is simple. The direction we have to calculate again. Okay. The direction, so E1 will be K 1 over 25, and the direction of U sub r will be the vector position from the source divided by the magnitude will be U sub r. The vector position will be 3i plus 4j divided by the magnitude, and the magnitude is square root of 3 square plus 4 square. So this is the vector E1, K over 25, 3 over 16 plus 9 is 25 square root 3 over 5i plus 4 over 5j. So we do the calculation of the force on Q3, taking out the charge, and calculated first the electrical field on this point. Second, it's a positive charge, the electrical field E1 will go like this, and if you represent this electrical field, will go like this. The electrical field E2 produced by the charge of 2 Coulomb will go up, E2. So what will be the expression for E2? E2 will be K over the distance square, 16, by the charge plus 2 Coulomb is the charge, by the unitary vector that is J. Why is the unitary vector J? Well, you see here is the vector that go from the source to the point, J, okay? So this is K over 8 J. And the total electrical force will be E1 plus E2, is the superposition principle is accepted, so K over 8 J have to be added with this term. So will be K over 25 by 5, 125, 3i, plus 4 over 5 plus 4 over 8. Oh, sorry, K. Sorry. It's K over 8. So let me put the K here also, K. Let me see if I'm making a mistake. K 25 by 5 is also 125 here, and 4 over 8, and now, yes, on the J direction. 4 over 125 plus 4 plus 1 over 8, and this is the K, So K, so this is the total electrical field. And what is the force? This is the electrical field at the position x equals 3, y equals 4. And what is the force on Q3? On Q3 is the charge. The charge was minus 3 Coulomb by E. But E is already calculated, it's all this expression. You calculate it and you end it. If you do it, you will see that it's exactly the same thing that we calculated before on the last example. Sorry if I made a mistake. Let me see if I make a mistake. E1 is K1 divided by U sub R. U sub R is 3I plus 4J divided by the magnitude. I don't know if I made a mistake from here to here. And E2 is K by the chart divided by the distance. Distance squared, 4 squared, 16 in the J direction. From the source is K over A, J. I don't make any, maybe here I made some mistake, but you correct it, and you have to prove me, or to prove yourself that this method is exactly the same method that we did when calculated FQ3 like FQ3 due to Q1 plus FQ3 due to Q2. It's the same method, the same result. Is the same result, this one, this result should be. So you do it by yourself. Good luck. I'll go for the next video.